tiny things called electrons.
Right. And we've looked at some great material that breaks down this whole process.
Yeah, our goal here is basically to unpack electron transfer, why it happens, what the results are. We want to help you get a really solid handle on these key ideas pretty quickly.
Okay, so let's start at the beginning. Atoms. We know they've got the nucleus, right? Protons, neutrons, and then electrons whizzing around.
But it's those outermost electrons, the valence electrons, that are the real players in chemistry. They're the ones on the front line available to interact.
Got it. And the main idea today is what happens when atoms, well, change how many of those valence electrons they have, either giving them up or grabbing more.
Exactly. Because when that number changes, the balance with the positive protons in the nucleus gets thrown off. The atom isn't neutral anymore.
It becomes charged, an ion.
Precisely, an ion. And that single change, gaining or losing an electron, it drives so much of what happens chemically.
Okay, let's tackle one side first. Losing electrons. What goes on when an atom actually sheds one or more of these valence electrons?
Well, electrons are negative. So if you lose negative charge, you're left with more positive protons compared to the electrons remaining.
Meaning the overall charge becomes positive.
Right. The atom turns into a positively charged ion. We call that a conistation.
And electrons don't just fall off, right? You need to pull them away from that positive nucleus. That takes energy.
It does. There's an energy cost. We call it ionization energy. It's the specific amount of energy needed to actually remove an electron from an atom.
Okay, let's use an example. Sodium, Na, is a common one.
Perfect example. Neutral sodium has 11 protons, 11 electrons, and critically, it's got just one electron sitting out there in its outermost shell.
So if sodium loses that one electron,
it becomes the sodium ion, Na. Still got 11 positive protons, but now only 10 negative electrons. That imbalance gives it a +1 charge.
All right, so the equation is just Na yields NaO plus an electron, EO.
Simple as that. Na, E, no plus E.
So who tends to do this? Which elements are likely to lose electrons and become these positive cations?
Generally speaking, it's the metals. Think of like the alkali metals, sodium, potassium.
Group 1 on the periodic table.
Yeah. And the alkaline earth metals like magnesium, calcium in group 2, also many of the transition metals.
Why them specifically?
They typically have lower ionization energies. Their outer electrons just aren't held as tightly as in other elements. It's easier to pluck them off.
Is there a bigger reason why they'd want to lose them, though? A driving force.
Oh, definitely. It comes back to stability. Atoms often lose electrons to achieve a more stable arrangement of electrons, one that usually looks like the configuration of the nearest noble gas.
Ah, the noble gases. Neon, argon. They're super stable, right?